Hey, have you noticed that the price of gold has taken a bit of a plunge?
So where is the money going to come from?
Simple. The yield has to go up. We're starting with 110 grams of RPPM and 680 grams of SNP Soviet-era pins, both weighed out and loaded into a 2-litre flask. Water goes in first, then nitric acid. The goal here is to dissolve the copper-based substrate underneath the gold plating. The nitric acid is doing its job. You can see the solution turning blue from the dissolved copper. Once the acid exhausts itself, we decant it through a fine sieve. That sieve is important. It catches any loose gold foils that have already separated from the pins. Fresh nitric acid goes back in, and the flask returns to the hot plate. We repeat this cycle: exhaust, decant, reload, until the base metal is fully dissolved. At some point during this process, gold shells start rising to the surface. That's the tell. When the copper substrate underneath is almost completely gone, the gold plating is left behind as a hollow shell. And notice these shells aren't tearing apart. They're holding the exact shape of the original pins. That means the plating here is extremely thick. Base metal dissolution is complete. Now I'm rinsing the pins repeatedly with water, pouring off and replacing until the rinse water runs clear with no blue tint. All that copper needs to be gone before we move forward. With the water rinses done, hydrochloric acid goes in for a chemical rinse. The reason is that nitric acid alone can leave behind certain base metal residues that it simply cannot shift. Hydrochloric acid tackles what the nitric couldn't. We decant that off as well. Now we're building aqua regia directly in the flask. Fresh hydrochloric acid goes in first, the flask goes on the hot plate, then a small amount of nitric acid is added and a lid is placed on top. The combination of hydrochloric and nitric acid creates aqua regia, one of the very few acid systems capable of dissolving gold. This is what takes those gold shells into solution. The lid sits loosely on top to contain the fumes while still allowing pressure to escape. Standard practice for this reaction. The aqua regia dissolution is done. The solution has been transferred to a beaker and sulfamic acid is being added now. The purpose is to destroy the excess nitric acid remaining in solution. I transferred everything back into the 2-litre flask to manage the reaction volume. There's a foaming risk here, and the larger flask gives it room. more sulfamic acid goes in until there's no further reaction. At that point, the nitric is fully decomposed and the solution is ready. I attempted vacuum filtration through a sintered glass filter at this stage, but it clogged almost immediately. The gold chloride solution goes back into the 2-litre flask and we move straight to precipitation. SMB, sodium metabisulfite, is being added to the gold chloride solution. At the right pH, this selectively precipitates the gold out of solution while the base metals remain dissolved. The gold drops as a fine mud in the barren liquid above it. The liquid is now being poured off and passed through a filter. The color of the barren solution will vary depending on what metals are present. Blue from copper, green from nickel chloride, or a mix of both. We filter it specifically to catch any fine gold dust that might be carried with it. All the gold mud is collected into the melting dish now. A little borax goes on top. It acts as a flux, dissolving base metal oxides that form during the melt and protecting the surface. The oxypropane torch goes on. The borax liquefies first at around 743 degrees, forming a glassy layer over the gold before the metal itself melts. The gold is fully molten now, moving and pooling freely in the dish. We keep the heat on until it's completely unified into a button. The button is on the scale, 33 grams. That's the recovered gold from the full 790 grams of starting material. It's fairly pure at this stage, but would need a second refining pass, another aqua regia to reach 99.99%. Astonishing yield, roughly 40 grams of gold per kilogram of pins. This material is in a completely different league to the miserable return from my previous video.